Now let's talk about these forces tab here. The first force we have here is the gravity force, which is negative 9.81 by default. And actually we don't have to add the gravity here in the before the output as we do in the fluid simulations, because it's just integrated in the solver. And you have the buoyancy force. In case you don't know what buoyancy means, it's just the floating force. So I think most of us are familiar with the meaning of buoyancy. But if you just have a ball and you try to make the you try to push the ball under the water, you will have you will be opposed by a force, and this force is just buoyancy, or the floating force. This force tries to make your ball floats again to the surface of the water, as long as your ball density is lower than the density of water. And actually your ball is full of air, so it will be its density will always be less than water. Okay, so this opposing force that tries to make objects float on the surface of the water is called buoyancy, and it's by default 13.08, and this is the typical value of the buoyancy force of water. Actually, you will not dig into the mass of the buoyancy, but you can just control the buoyancy by the depth, or in another meaning, the distance of the particle of our foam from water. Okay, and we have discussed this idea before. We have this base advection strength, which is the strength of the advection force. Advection is just moving the foam with the velocity of our simulation. So surely your white water will match or move with the velocity of your fluid simulation in order to get just the shape of your simulation. Okay, so when you just increase the base advection strength, the particles will be advected more with the velocity of the simulation. Okay, and I think I have made some tests of this parameter here to get the sense of it, although that I don't change it, and I think I didn't change it in my simulation. We have advection by depth, which is the same idea. This control of advection by the depth of the particle or the distance from the surface, either if it's positive or negative, as we have discussed before. And we have this base velocity multiplier, and this multiplies the velocity of our simulation before we advect the particle by this velocity. Actually, you have just imported the volume and the volumes in the solver. I think here the volumes, emission source, and we have volume source here. We have imported our volumes that contain the velocity volume. Okay, and actually each frame you have this velocity volume prepared for the advection of the foam along it, and this makes your white water simulations. Okay, so we can just add a multiplier or change the value of the velocity volume before we advect the particle with it, and this will change the look of our simulation. So if we change this to something like 5, this will make your white water moves faster. Okay, and this later one here is a multiplier by depth. Okay, this is another multiplier of the velocity of our simulation by depth. You can have particles that in this depth, for example, you can make them have no velocity. Okay, and this is just an extra control that we don't use it but you may use these things in your simulations. So let us see the test of the base advection strength. So I've made this test with my simulation, or my whitewater simulation. Okay, I don't know why this is not working. It's not. So here is the I've made the preview here in play, because I have had mistakes redeeming or something wrong. Okay, anyway, here is base advection. I think this is 2, okay, and this is base advection of 1, and as you can see, the particles here are more advected with our velocity. Okay, you see here this, it makes this trail-like effect that I don't like, and I don't like in the end of simulation. So base advection, I will make this value as smaller as possible, because I don't want these trails here because of aggressive advection. Okay, so this is for base advection, and actually with the base velocity multiplier you will get something very similar if you increase it like this. I have increased it, and it makes this sort of trails when my whitewater goes to the ground. Okay, and when it goes up, it makes this kind of trail that you may like, but I don't like. We'll discuss the values that I've used in my simulation in the next video. Thank you for watching.